In this video, we're going to walk through all of the steps to build this cup with a handle from scratch in TrueGrid without reading in a CAD file and using only one block part. It's best to follow along with TrueGrid open in another window and pause this video to complete the steps on your own. You will learn many techniques that you will apply to everyday mesh building by completing this exercise. You will find the pages shown here in your training manual. And as always, you can copy and paste the commands from the pages into the TrueGrid text box if you wish.
One might argue, well, let's do the handle separately, but it doesn't turn out to be any easier. So let's build it all as one part. And I first start out with a rough draft of a diagram, looking at features. For example, the handle to the coffee mug has a top and a bottom for the top part of the handle. That's a feature, and you have to have a partition in the mesh for that feature. And that's what this is here. This is the top part of the top handle, and this is the bottom part of the top handle. Similarly, for the bottom part of the handle, there are going to be two partitions to capture that feature. Notice too that we have two partitions at the very bottom because we have to have a bottom in the cup and it's going to have some thickness. But the most important feature of this coffee mug is that it's a cylinder. It's a modified cylinder. And so we want to use a topology for cylinders. You look at the big features first and say, now this is the basic structure of our part, of our model, and then you work in the rest of the details. Now, a coffee mug, a cylinder, has a block in the middle, and then radiating out are 4 blocks that form the rest of the base. Now, you've seen this pattern before, and we have a name for this. We call it the butterfly topology. And it's the most common topology. It's basically the only topology we have to deal with curvature, and it deals with curvature quite well. So we draw our diagram. You always want to draw a diagram. Take a piece of paper, draw the diagram. And here we have our cylindrical mesh. And then we have 2 layers out here, two partitions all the way around. This will be the thickness of the wall for this cup. And here we have the handle. Now, one of the basic principles of mesh topology is that topology goes all the way through. If we're going to do a single part, that is, we don't just tack the handle on at this point and then be done with it. You have to put in a partition or two in order to have a place to attach the handle to the mug. And that topology goes all the way through to the other side. That's an important principle of HexMesh generation in general. The topology goes all the way through. That's why HexMesh generation is so difficult. You use tetrahedrons. You can throw them together any way you want. So we start with this idea and we put in some dimensions. For instance, these 2 cylinders are going to have a radius of 2 and a radius of 2.1. So the thickness of the wall is going to be a 0.1. Now, when I do a topology like this, the butterfly topology, I typically come out 1/3 of the way for this block. So if this is 2 inches or 2 units, this is going to be 2/3. Now I'm assuming we'll put this at the center of our coordinate system. So 0, 0, 0 will be here. So this will come out to 2/3, this will come out to 2, and this one will be out to 2 and 0.1. We also need to know what the z coordinate is. We start out at z0 and give the bottom a thickness of 0.1. And then the handle, the bottom part of the handle is going to be at 1.1 to 1.3. And the top part of the handle is 3.1 to 3.4. And then the very top is 4.3. From this, we then have to decide how to build the block command. So we assign directions in the mesh. We have I going in this direction, coinciding with X. We have J going in this direction, coinciding with Y. And then we have K starting down here and going up. So one of the easiest things to do is to count the number of partitions in each of the 3 directions, and then only put 2 elements in each block. Later, we can add elements to get a smooth mesh. But right now, it's a bit presumptuous to know exactly how many we're going to need. So let's just put in 2 elements per, and that makes it very easy to build the block command initially. So how many partitions do we need in the I direction? Well, there's this outer and then the inner. That's 2 partitions. Here's the third one, 4, 5, 6, 7, and 8. So we have 8 partitions in the X direction. In the Y direction, or the J direction, we have 2, 3, 4, 5, 6, 7, 8. So we have 8 in the J direction as well. And in the Z direction, we have 2, 4, 6, 7. So there's 1 less in the Z direction. Let's do that first, and then we'll come back and figure out what numbers we should use for the X, Y, and Z list. We'll start fresh with a block command, and we'll use 8 partitions. We start at node 1 and then add 2 elements. 3. That's our second partition. 5, 7, 9, 11, and 13. I think that's 8 of them. 2, 4, 6, 7. No, I need 15 as well. There's 8 of them. 2, 4, 6, 8 of them. And we do the same in the J direction. 1, 3, 5, 7, 9, 11, 13, 15. And in the K direction, we have 1 less. 1, 3, 5, 7, 9, 11, 13. Enter. So now we have our block topology for our mesh. Let's now put in the coordinates. So in the X direction, we're at 0 down the middle. So over here, we're going to have a minus 2.1 for the outer cylinder. And then this inner cylinder will be at a minus 2. This will be at a minus 0.6. And then we reflect that. In other words, 0.6, 2, and 2.1. And then finally, we want to put on the handle, and the handle, it'll be X 3.1 and 3.4. Now in the Y direction, we have almost the same thing, but we don't have the handle in the same direction. So we'll start in the Y direction down here at the negative end with a minus 2.1, minus 2, minus 0.6, and then we have the handle partitions, and they're a minus 0.1 to a 0.1. That's these two Y coordinates. And then, of course, it repeats in the mirror side. So it's 0, 0.1, 1.1.1, and then 1.3, and then 3.1, 3.4, and then 4.3. So this is what we do all the time when we're building a part, is we draw this diagram. Now remember, we've got our full indices, reduced indices, and our coordinates. And in this part, we have to delete a lot of the blocks. But that's going to be difficult. I look at this block and I don't know where to start. And that's why the diagram on the second page is so important. It's part of planning to make it easy. This is our block showing just the partitions, not the elements in each block. Right now we have 2 elements in each block. So we're going to delete some things. First of all, we have this butterfly topology, which means we have to take away 4 corners to be able to pinch the corners together and form a smooth curved object. What I'm going to do is cut out the block that fit in between these 2 blocks. That's the corner. We throw it away. So I'm going to throw away these blocks right here all the way through, because I'm going to glue this edge to this edge. Similarly, I want to do it over here. So these 2 blue X's represent a deletion that goes all the way through. Similarly, up here, all of these blocks have to be cut out all the way through. So for all 4 of these blue X's, we're going to go all the way through. Let's do that first. Now, how do we do that? Well, let's look at the partition numbers. For this X in the I direction, we're going to delete the first 2 blocks, skip a block, and delete everything else. You see, we're using this diagram to map our steps out. I go to the I index bar. I need to delete the first 2 blocks. So I do a click and drag from 1 to 3. And then I skip 1 and then do all the rest. Now we're going to delete the blue X's in the J direction. So it's the first 2 and the last 2 that have to be deleted in the J direction. So we're going to, in the J direction, do the first 2 and the last 2. Click on delete. The next step is this big red X. This is to hollow out the inside of the cup. In the I direction, select from the second partition to the fifth, from 2 to 5. And for the J direction, it's 2 to 7. I hit F2, and then I select from 2 to 5 in the I direction, and 2 to 7 in the J. Now we don't want all the way through the K, because then we would have no bottom to our coffee mug. Remember that if you don't select anything on an index bar, then TrueGrid assumes all of it. And that's what it's doing here. If we click on delete, we won't have a bottom to our coffee mug. So we want to select from 2 to 7 in the K direction, preserving the bottom layer. And so now we click on delete. Now I know this doesn't exactly look like a coffee mug, but we're getting closer. We now want to delete things around the handle, and then we'll start shaping it. We need to delete this block and the one on the other side. Now, if you recall, when you make selections in the computational window, you can only do one block. But then you can go to the index bar and augment it with more. By clicking on 5 to 6 in the J direction, I'm able to select the second block that has to be deleted. These two golden X's that are going to be deleted all the way through the bottom. And that's what I've done here is I've selected those where the golden X's were located. So then I click on delete. Now we're going to delete portions of the regions above and below the handle. I know for the fact that we're going to delete that pair of blocks. And something similar down here will have 2 thick. So I'll come back to the K index and go from 1 to 3 to get these two in the K direction. This pair of blocks and these 4 blocks, but they're in the middle here. These have already been deleted in this region. So I'm going to delete 4 on the bottom and 2 at the top. And that's what I've done. 2 at the top and 4 at the bottom. So I click on delete. We've almost got all of the blocks removed that we don't need. In fact, there's only one more that we need to get rid of. And that's this one right here that goes all the way through. Select a face, because that's all I can select in this picture. And then I go up here to the J index, turn off the selection, the 4, so it goes all the way through. Or I could do a 4 to 5. Either way, I accomplish the same thing. So that's where your hand would wrap around on the inside, and we delete that. So now we have our raw block topology for the coffee mug. Now we're going to use projection and a few other techniques to shape the coffee mug. So first of all, we need 2 cylinders, one of them with a radius of 2 and the other with a radius of 2.1. So we go to the surface definition menu, SD, surface number 1 will be a cylinder going through the origin, so 0, 0, 0. And the direction of the axis of symmetry will be the z-axis, so it'll be 0, 0, 1 with a radius of 2. And execute and quit. So that gets us the inside cylinder. Now we need to do something similar for the outside cylinder. So SD, surface 2, it's also a cylinder going through 0, 0, 0 with 0, 0, 1 as the axis with a radius of 2.1. Now the outer cylinder is going to be projected to by this face and this face and this face. Now can we select a solid that has all of those faces as its bounding faces? I think so. So we'll start in the eye. When I put the mouse close to 1 on the eye direction, I get the first face that I want to capture. So I go from here and I just continue marching along until it gets to the outer face of this block here. There we have it. Now to be complete, We also have to do it in the J and the K direction. But I can tell you now, we don't really need to do anything in the K because we're not going to select the bottom or the top. We're only selecting things around the outer faces of the coffee mug. So we can leave K alone. But in J, we want to be sure to select the entire interval because we're going to select the outer faces of this solid, including in the J direction, by selecting the nodes at the ends of the intervals. So for the I, we're going from 1 to 6, so we click on the 1 and we click on the 6, and that gets us two of the faces that we want. And in the J, we do the same thing. Click on the J1 and the J8. And now you can see here that all the faces that are supposed to be on the cylinder have been selected. So now we select the outer cylinder, which is problematic because they're very close together. So the best way to handle that is to go to the Labels panel in the Environment window and tell it to number the surfaces. So we want to pick by label. Come over here and pick the number 2. So now I've got the faces of my mesh and the outer cylinder selected. Click on Project. Now what we want to do is to select the inner faces. So the best way to do that is to start over by clicking on F2. This time we don't start at 1 in the I direction, we start at 2 and do a click and drag until we get to the opposite face of that inside. So it's from nodes 2 to 5 in the I direction. In the J direction, I can see that there's one block that we don't want on each end. So I'll start at J2 and go all the way to 7. And now I have selected the solid that has, as part of its property, the walls of the inner part of the cup. We now go back and click on the end nodes 2 and 5 in the I direction, 2 and 7 in the J direction. And sure enough, we now have the inner faces of our coffee mugs selected. Notice that they go all the way through the thickness of the bottom of the cup. All right, so we now select the cylinder number 1 by clicking on the 1 and click on Project. We have now finished projecting. We can remove these two cylinders from the picture. So I go to Display List, Surface, Show None. And you can see a little bit of curvature here. That's an improvement. But now we have to close the gap. Now, when I did the sphere and that example where I did a disk, I started the outer blocks at 0 thickness. They were collapsed to the inner blocks. And so we didn't have to worry about how do you get one side and another to meet in the middle. It just happened because of the way the projection method works. This is more complicated. We have to have new means in which to get this face over here and to get this face over here so that they meet perfectly. Now we're going to take advantage of the projection method to do that. We're going to create another surface. This is going to be a plane at a diagonal, and we're going to project this face and this face onto that diagonal plane. Okay, so let's build surface number 3. SD, surface number 3. It's going to be a plane defined by a point and a normal. And the point is going to be 0, 0, 0. Well, we want that plane to have a normal pointing in this direction at 45. So that's going to be a -1 in the X and a +1 in the Y, and 0 for the Z. Now, like I said, we're going to take advantage of the projection method. We're going to project this face to that plane. But I like to select the face by looking at my computational window. It's easier to select. So I'm going to select this face right here. That's this one right here. And then I'm going to pick this surface labeled 3 and project. Now, why did that happen? You see, we already had this face constrained to be on the cylinder. No matter what we did, it's going to be on that cylinder. And then we constrained this face to be on that diagonal surface, that diagonal plane. That means that this edge must be located at the intersection of the cylinder and the plane. And that's exactly what happened. That edge is now on that intersection of those two surfaces. Turning off the first projection and the second projection, the two cylinders. It's not radically different. Keep in mind it's moving to the closest point. So if it started right around here, it projected closest point on the plane. But it's not on the cylinder. So I'll turn those back on again. Now we're going to do the same thing for this face right here. We select that face, we select the surface, and project. And they now are connected. The coffee mug is now watertight at this corner. They're perfectly matched. Now we could do this at all four corners and be done, but that's too easy. I'm going to show you 3 other ways. And each one of these ways is going to challenge your understanding of the projection method. So the next thing we're going to do is change the initial coordinates of all the nodes along this face. I'll select the face, and I'm going to choose coordinates of, in the x direction, a -2, and in the y direction, a +2. So what I'm going to do is modify the coordinates of all of the nodes here. So I go to the main menu, Mesh, the PB command for placement, placing a block. I hit F1, and I'm going to modify both the x and the y coordinates. The x is going to be a -2, and the y is going to be a +2. And when I redraw, it's in position. Now, why did that happen? It's happened because we changed the initial position of these nodes so that when they projected to the cylinder, they projected along the 45-degree angle because the coordinates we used were on the 45-degree angle. And now we're going to do the same to the opposite face. The point being that if you start 2 things out in basically the same location and then project, they're going to end up in the same location. Hit F1, X and Y, -2 and a 2. And now we have closed the second gap. Now the next approach to this problem is to create a 3D curve. And I'm going to make it a very simple curve. It's going to be a vertical line at a -2 in the X and a -2 in the Y. So I go to 3D curves. I use the curve command, curve number 1. It's going to be a polygonal curve, a 3D polygonal curve. So I give it the x, y, and z of the starting and the x, y, z of the end. So it's going to be a -2 for the x, -2 for the y, and a 0 for the z. That's the starting point of this line segment, and the ending point will also be a -2 in the x, a -2 in the y, but let's put 5 in the z. And here's that line. Now what we're going to do is something similar to what we did here. Here we changed the coordinates. Here we're going to attach to a 3D curve. In each way, we are reinitializing the coordinates of the nodes so that they project where we want it to project. To do that, I need to select edges now, not faces. So I'll select this inner edge first of this face, select the curve, and we use attach. Attach is the same as initialization. So it attached to this curve and then bounced onto the back or projected back the cylinder. And we do the same with this edge. And the same for the 2 edges on this other face. And that closes off the 3rd corner. The 4th corner we're going to do a little differently. It's not going to be precise, or at least it won't seem to be precise. We're going to use the rotation feature under Move Points to move one of the faces into position. And then we're going to glue the other face to that one. I'm going to use the rotation to move this face along the diagonal. And I want to be as precise as I can. So I click on the Restore button and then center so it gets as large as I can get it. And then I go to Move Points by Rotation. I'm going to find the center and click with the left mouse button. And if I've done a good job of selecting the center, this is going to be quite close to match the others. So I just simply rotate. And by the way, you move the mouse further away, you have greater accuracy when you do the rotation. So I try to stop at 45 degrees and let go. And now that face has been reinitialized to this location and then projected. Now the problem is that I can't be perfect about rotating this one into the right position. It's going to be approximate, and I don't want that. I want it exact. So I'm going to use a different method. I'm going to use the X and Y coordinate of one of these inner edged nodes to reinitialize the X and Y coordinates of this edge. So I will select the inner edge of this face. And I want it to have the same coordinates as XY coordinates as on this face. So I go to pick a node and I'm going to turn off the Z. I only want X and Y. Over here and I click and get the node closest to where I clicked, which happens to be on that inner edge. And now I'm going to attach. It's going to change the coordinates, X and Y coordinates of this edge to match the X and Y coordinate of this edge. So I click on Attach. And now we'll do the same for this outer edge. I'll match it with a node on the outer edge of the opposite face and attach. And now they are perfectly matched as well. And now all four corners have been closed. Let's add some elements. Now we do that by adding elements one block at a time in each of the three directions. We'll start in the I direction. So we go to the main menu, Mesh, MSEC, that's for modifying the sequence in the block command, I direction. And then I use the computational window to help me. So the first interval that I need to select is highlighted. That's the thickness of the wall. But I think that 2 elements is plenty thick. So for the first block, I'm going to put down 0, no change. Now the second block is the number of elements is in this direction, and right now it's 2. But if I change this, if I say, well, let's put in another 6 elements, then I need to be sure to add 6 elements here so that they both match at the interface. But if I change this to have 8 nodes or add 6 nodes, then I need to add them here too, because of this interface between these 2 blocks. And consequently, I also have to add them here. So there are constraints as to what I can add and subtract. Let's make that 6 more elements. Now this middle block, we want to choose 6 as well, because they may not be too big here, but they get big out here. So let's add 6 to that. Now we already know that we have to add 6 here because we added 6 here. It has to be symmetric. So we'll put 6 more. And we already know that there's 0 here being added, so that has to be the same here because those constraints march all the way around as well. So it'll be 0. And then for this interval, maybe 4 more elements would be sufficient. And I think we have enough here, so that'll be 0. So now I've got a number for the change in elements for each of the intervals. Execute and quit and redraw. Now we do the same in the J direction. So I go to 0 for the wall and then 6. But now if I'm going to have 8 elements here, I want 8 elements here, and I've already got 6. So I'm going to add 1 here. I won't add any here, and I'll add 1 here. 1, 0, 1, 6, and 0. And finally, let's put some elements in the Z direction. We have enough here. enough here, and enough here. So we're going to have 0, another 0, and another 0. So let's go to MSec. In the k direction, the first one is 0, and then maybe we put in 2 more elements here, and then 0, 4 more elements here, and then another 0 for this interval, and then maybe 1 more here. I'm going to go to display list, curve, show none, and now I have my coffee mug.